Hi, welcome to the Linux channel. See, the last episode I've discussed about a roadmap for becoming a system software developer, and I have shown a sort of like a Venn diagram, as you can see here. The way, no matter which direction you go, let it be towards core device driver development or any microcontroller programming, and as well kernel bootloader or embedded firmware development and stuff like that. No matter which direction you go, there is always some overlap you will find. The common thing amongst all is generally we expect any developer we hire or get any expert should also have some of these skills. Hence I put that middle part, which includes core system software skills, let it be some user space stuff as well as the kernel stuff. Hence I put this in the middle. So what I thought is I can take a sort of overview in this episode. I can cover some overview in this episode as a part of second episode of this series. And before going further, I can also recommend you can refer my old video about roadmap of becoming a kernel developer. So if you search somewhere, you should able to find roadmap, and you will find my old video. Yeah, you can see there that I shot around June of 2020. It's quite old, and the one which I shot earlier is on last week around February 19th of 2022. So you can refer this Linux kernel developer roadmap. This is all about kernel developer, so hence it comes somewhere here. So the things it will help you to follow or get to that roadmap is to become a kernel developer, and so a device driver developer in the Linux kernel and stuff like that. So overall core operating system development stuff. So in this episode we cover about as a whole system software development, like how you can approach. So before going further, again this episode I want to bifurcate into few sections. Okay, see, one is you can be a complete college student. Let's just put this 4 quadrants. I'm not sure about the other quadrants. Let's just populate and see how many sections we can divide the demographics actually. Okay, so one is entirely college students, okay, who are still studying and stuff like that, and sometimes over here could be freshers who just finished college and they are looking for choosing a specific direction in their career, or a depth in their career. So some can be freshers, and also it can include working professionals and stuff like that. Or sometimes I can better even make this demographic over here. We can completely make this into a different section. Working professionals, so they are working in some domain and they want to get into the overall system software development, or they are curious to learn about systems. Okay, so things like that. And the other we can call maybe miscellaneous. They just are curious, and I have some students in this category. I have some large number of students in this miscellaneous category. That includes even guys like CEOs and CTOs, because they just want to see how they can position their product and stuff like that. So there is a unique reason why they come as a student. So you should understand that when we use the word student, it's not somebody who is just going to college or something. I have students who are literally a CEO of a company and he is an expert in cloud and other technologies, but at the same time he want to find some ways to optimize his how to say his product offering, solution offering and stuff like that. So there are some few reasons, hence I do get students who are even a CTO or a CEO. Okay, there are some exceptions like that. So hence they are looking for workflow optimization. They are also looking for product optimization and stuff like that. So they gain this expertise, and they can see that if there is any performance bottlenecks, they can mitigate. There is any network bottlenecks somewhere, there is something which is not performing well, they can identify and try to mitigate. Hence these are various reasons they come to me as students. Hence we put them under this miscellaneous. So because they are sort of business owners, and also they are sort of co-founders and stuff like that. So this is one category they are coming, because to know and to optimize. This also includes interestingly even cybersec guys, okay, all these ethical hackers, cybersec analysts and stuff like that. And also I have also few DevOps, okay, students. I have some bunch of DevOps guys who also again curious to debug any issues and optimize the workflow and stuff like that. Hence they do come and join as students, because another reason for DevOps is since they play around with containers and virtualization and automation of that, sometimes they hit upon various again performance and security issues. So that is also one reason. Hence I put in these quadrants. Okay, so apart from that, working professionals, these guys are like having 5+ years of industry experience, 15+ years of industry experience, 10+ years of industry experience in and around in software development and stuff like that. And they want to know about the systems aspect in a much deeper level. And since these guys are coming from industry, they know generally some fundamentals and stuff. See, they are not interested with college level of college student level of expectations. So they are completely different. Hence the reason I felt, see, before even I start about this, I need to first identify this target audience. Okay, these are various types of target audience. So these guys know how the software development life cycle. They have done projects, they have released projects, they have done bug fixing, they have done even some have architected the code modules, whatever it is. They have done documentation, HLD, LLD, FRS and stuff like that. Okay, so they have done all those phases, but they are not essentially from this domain. Okay, but they are curious. Some want to shift. There are who are around 5+, 8+, or 2+, 3+. They expect that I am working on this, but I want to shift my expertise and gain domain expertise and get into this domain for so and so reasons. Hence these are working professionals, so they know what they are doing and they know what they are supposed to learn, and they are really passionate or interested for whatever reasons. That can be passion or it can be economically driven. Okay, so that is this category. And in this category, even recently I got recently sometime I think last year, not recently. So I got a guy who is preparing various systems aspects, but he's stuck. This guy is from abroad. He's not in Indian. He is not Indian, and he's preparing and he is thinking to migrate to some country. But he had enrolled several courses and he want to see what he can do next and how he can approach companies in terms of getting a job and things like that. And he has some contacts in few companies like Facebook, Google and stuff. But again, he is still confused, like how he can approach and what he can focus in terms of gaining certain skills and stuff. So again, I'm saying working professionals, they know what the industry is, so let's put them in a different category. So next comes this freshers. They are complete freshers most of the time. So I can sometimes include 1+ also 2+ years who are working professionals, or also can be called as freshers, and somebody who have no experience, so which is also this 0 experience freshers, and sometimes who are in their final year college. Let's consider them as freshers, because in few months anyway they are going to be freshers. So all this comes under this fresher category. And when it comes to college students, so now it can be 1+, it can be even I do get somebody who is about to join college, but they are very interested. They are like a sort of prodigy also, so they are very curious, very interested. They know many things already, and they are very interested and eager to get into this. So sometimes you will find like this 1 plus and second year of college or third year of college, okay, something like that. So let's consider all these guys, okay, and as well as apart from bachelors who are doing their masters, who are doing their PhDs and stuff like that. Of course, although being a graduate, I do have a lot of PhD students and master students, so there is no there is no need to get confused that somebody have done bachelor's, how we can teach masters or a PhD guy, because this happens a barrier if you are in a education system, because if you have to teach your students, you need to be much more qualified and stuff like that, but it doesn't happen like that in the industry. So that is not the way it works actually. Hence, let's put all these category of guys in this part, because these guys also, although somebody have done masters, he never worked, okay, so he never knows what the real industry is. Same way somebody is doing his doctorate or PhD, whatever, they have never worked, and so they still don't know how the industry works and things like that. They may work on theses and stuff. So let's split into these demographics. So let's go back and see there. Okay, see what I said is you want to get into system software, focus also this common thing, which is this general user space stuff and the kernel space stuff. So what I meant, the user space stuff is let's say you learn the C basics. As one can understand, the C is very commonly used language for writing any system software development. You can also combine C with inline assembly and stuff like that. And in the Linux kernel, you will always find a lot of spaces, a lot of places you will have inline assembly inside the C code. This is done because it is more critical CPU optimized code. Hence you will find such a thing mostly found in this Arch folder. As you see here, the Arch folder itself is CPU specific, and here various APIs, let us say memcopy, strcpy, memset, and what is that, kmalloc and kzmalloc, which is 0 bytes you assign, and then you alloc and then assign 0 bytes. All such APIs can be optimized, because if you include inline assembly, you can make it highly optimized code. So some of these fundamental APIs are used throughout the kernel. Hence it makes sense that all these APIs are highly optimized, so that you use it any iterations, it is all what you are getting is an optimized API. And this is one question somebody have asked about the difference between function and an API. So since I use the word API, I don't use the word function. So if you are from college, okay, you guys will use this structures, function and all this nonsense, versus me being from the industry, I use the word API. See, what I meant by API is you write functions and you give these functions for somebody to use, okay. Hence, if you give this somebody to use, we better call them as APIs, because he don't need to worry about the internals of the functions. The guy who uses them is going to bother about how to use that function. So he is not going to bother about how those internals work. Hence, the API is the commerce part, what you give to others. The function is something you do yourself. So let's imagine we take a code. Okay, you take a code like this. Let's imagine you have this abc.c something, and it has also some abc.h something like that, and it can be independent library or something like that. And let's imagine you have written some functions, function 1 and doing something, it is taking something, again function 2, it is also doing something. And let's imagine you export these functions, and somebody can include this function and they can use those functions. But you have also written some few helper APIs or helper functions. So let's imagine you are writing some static, and you are writing some function here, some function here, some function, and this function is actually called over here actually as a helper function. So it is called over here, something like that, it is called over here. So this function is getting called over here, but it is a static function, it is not given to outsider use. Hence, this is what a developer typically writes. So this whole thing constitutes what a dev does. So in his point of view, these are going to be like functions actually, right? And if you give to somebody else, he is not going to bother about what this nonsense is. He is going to bother about what you give these functions for his use case. So all he is going to get is function 1, okay, it does the so stuff, he will get the documentation, and function 2, it's going to do something and some documentation about it. So for him, all he is bothered about is this APIs. Okay, so it's the commerce part, because sometimes if you sell this to others, or you make it in make it open source, put it in GitHub or something, you give to others, all is going to bother about is those APIs. External APIs is not going to bother about your internal guts of your library or your code. So we can take any example. Let's say you take for example a simple stuff like say read a file in C. So let's take any source code, sample source code. Just we take any sample source code from any random website. Okay, let's just take a source code like this. See here, you can see there include stdio and then include stdlib, and you are doing this function file pointer, and then you are doing an fopen and you are checking if it is successful. If it is not, throw an error, come out, and if it is successful, do a scan of printf whatever it is, and or get file as whatever, you do that and read the contents, and then you are doing an fclose and closing that file gracefully. So you can see there in all this transaction you are using this file pointer. Once it is successfully created, you are using the same file pointer and using everywhere fscanf and then fclose and stuff. So these are those file access functions or those APIs. So hence you don't bother how this itself is coded actually, what is the source code of fopen. So you are not going to work in that library which is coming from stdi or stdlib or something. It is not your scope of work, let's assume. So you are going to bother only about how that API can be used. Hence be clear that you use the word API is a better word than you use the word function. I feel it is childish if somebody says that this function does this. Actually you are still a kid is what I can think about. So use the word API. It refers that commerce aspect, it refers that what the deliverables others are getting. Hence I'm saying, let's go back and come here. So you can see here the system software and the kernel space. So as a part of system software, you will be learning about C programming as a part of that, or else let's consider even C++, the non UI type of C++ code, which you can do rich user space engines and daemons and stuff like that with C++ instead of C. Okay, either way, C or C++. I'm saying that core C++, which is not the UI type of C++. Okay, so in that case you will be doing any multi-threaded applications and multi-process applications. You can do any web servers, you can do any network engines, you can do any database engine. Let's consider MySQL database engine, okay, or any interpreters. You have this Python interpreter, PHP interpreter, all these things which you do in the user space, you can consider as system software programming, because this is going to lay around close to the kernel space, and it is going to interact kernel in various ways, via system calls or via proc or sysfs or whatever it is, and this is going to do that low level services in the user space. So it is although it is in user space, it is just one level above the kernel. Okay, it's not to be considered as strictly applications either, and sometimes it can be for instance, take this glibc project. Okay, I still remember guys who I know who works in that glibc project also. So you think about those things. Okay, you are working on C compiler itself, but you are doing a very much low level kind of a stuff which enables others to compile programs and do things actually. Hence we still can call that as system software development actually. So in my case, if you ask me, the traffic squeezer code I have done in the kernel space, of course ignoring the UI part, and later recently I moved it to user space, the whole packet processing engines and stuff. So although I moved to user space, still it is a system software project. I mean it is still a system software components. It's just moved from kernel space to user space to ease some of the difficulties I used to face constantly by doing kernel space development. Okay, hence I'm saying just because it is moved to user space, it is not any it's not any application development. It is more to do with system software development still actually. Hence I'm saying there is a difference between end user facing applications like this, this Firefox or this sort of applications like this, Chrome and stuff like that, versus there are other libraries and other stuff which are going to work behind the scenes. Hence we can consider as user space. So the line is totally blurred. What I meant is you have the kernel space here, okay. Do we need to consider only working in kernel is system software, or do we need to think there are some few libraries and other layers over here which are running in user space, but these are low level stuff, okay. It can be libraries, it can be any sort of engine, okay, it can be a database engine, stuff like that, and on top is more user centric apps, it can be UI apps, etc. okay, so stuff like that. So hence on top of it you have various UI apps and stuff. If you ask about the kernel doesn't care. It's just going to see this is kernel space, the whole thing is user space, okay. So that's how the distinction is. So this is how the distinction is. So that doesn't mean anything you do in user space is going to be application development. It is not actually. It depends on which layer you work and what sort of components you work. Hence I still classify if you work in any of this sort of middle layer or something like that, which the boundary is blurred. See, what I meant is the whole boundary is blurred, okay. This boundary is blurred, versus if you go from here to here, definitely this is like a user centric applications. So this is more like any other app development. It cannot be called 80% of the times as system software development, versus here we can still claim as a system software development, okay. It can be any sort of VPN solution, it can be anything like that, okay. So that's why I said my own stuff, WANOP stuff, it was here and it's been moved recently over here. Although whatever it does in kernel space, almost the same it does in user space, I just managed to move it here. All I do these days is I give the packets from here to here and I get back the packets and transfer it from the kernel, rather than doing everything within the kernel. So because it has such an architecture, I can't say it as user space application, although it works in user space like any process, okay. So that's why, hence I am saying consider this. So get some mastery over this multi-threading, multi-processing, and don't read the theories. You apply real world examples, real world stuff, like I always say, and try to see where it fits real world, okay. And don't sit and read theories, it will not help. No matter how much you learn, thread is all part of one process is different PID, and you have the PCB versus threads have a common process control block. No matter whatever you learn, it's not going to help you much. I mean, this is a person from the industry can give input like this, because the same thing if you hear from anybody coming from institute, they will have a different approach, versus as you always seen me, I have a different approach and a different explanation. So leave all that bullshit. I'm saying is the bottom line is, why the hell you do multi-threading, why the hell you do multi-processing. Again, this is something I have done in the past several videos, and I have done several episodes and series about it. So perhaps somewhere you can search okay, something like that. You'll find various episodes. So again, if you want a general YouTube search, you can still do the Linux channel threads process something, and you can find, or you can go to the website also, and okay, you can go to this videos tab and then go to that relevant section. This is where user space, and then you can click, and then somewhere you can navigate and find. But again, you can do a Google search and you'll get it also. Okay, so hence I'm saying those things are there, those things are done in user space, but it comes under the category of systems software development because of this, you know, blurred lines. Okay, hence, you know, gain some mastery. Okay, that's what I meant over here. User space, system software, and then the kernel space is quite obvious. So you learn about the operating system, the components of OS, various modules like memory management and scheduler and stuff like that. And as an example, you can learn the Linux kernel itself, and you have various books available. Like again, I said, if you are really keen, you can watch my previous episode about that roadmap stuff about kernel development. It is good enough, which will explain something what is what actually. So go there, and one of the important things I highlighted is if you want to become a driver development guy, or you want to become any OS kernel bring up, or kernel, I mean board bring up with a custom kernel or any kernel porting and stuff like that, you know, start with doing a code walk of the kernel source itself. Okay, have a book as a reference, that's fine, but the book is already old. There's no point in, you know, you referring any books. So open the kernel source code and navigate and try to understand. And also, as I said, if you go to this you know, documentation folder, there are a lot of official documentation available in the Linux kernel itself. Okay, so go there, navigate and have a look before, you know, you read from some random source, because that's done by a random author. It is his opinion, versus this is done by the module authors actually. Suppose if I submit any module to kernel source, to mainline kernel, then this document is written by me itself. So you won't find any sort of third person's perspective, you know, thing actually. Hence, if you read any random book, the author, whatever he perceived, he is writing that his thoughts in that book, and unfortunately with obsolete examples, because the book is published maybe a decade ago and now the kernel is completely different. Hence I'm saying, just don't stick with that. Go here and see this you know, documentation. This is mostly coming from the main module authors. So one of the, you know, documentation which helped me a lot is, I was checking for eBPF and I found there is a official documentation for that. So you can go here, networking, and you can find something called filter actually, and they have given fantastic examples. See there, this is blah 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 blah, the whole background information, and then you can see the original paper is what, and then this data structures, and then they have also given a sample user space code in kernel documentation, how you can do, and also the sock ops, how you can pass this code via socket options, that they had given, and so much details, how you can navigate, how you can get it in various format of that assembly code, because this is a eBPF. So hence you can see that the same code in various format, and so I can't ask better than this actually. I find this documentation is more than enough, is what exactly I'm looking for when I was initially exploring about this. So hence I'm saying, sometimes you go and refer this and you will find the documentation from the module authors itself. So that's the best documentation ever you can get to start with, and then you can go with any random books. So hence I'm saying, if your students, I also find one of the big confusion and dilemma is, they may have some college assignments, they may have some college commitment, they may do some work assignment or paper or something. For that reason, they just one day they just try to, you know, get all these concepts and try to do that assignment, and then they look for any external help. Unfortunately, I pity on them, because that's not the way you should ever learn anything. It's just the most dumbest way you can do anything in your life, because the thing is, you have no background you know, idea what is what, and just because you need to finish some assignment and finish that commitment, and you just want to do something random learning here and there, and you are trying to put back things together. Unfortunately, this is actually not a mistake of students either. This is how these education institutes do actually. I mean, this is how they operate because they teach all this random spicy stuff. One day they teach about something, the other day they teach about something, then again they summarize everything, and then they give some tasks to the students. It's just the most stupidest way you can approach when it comes to that. So that's not the way even industry works. Hence I'm saying it's not good, but you are under pressure, you are supposed to finish this, and you are getting some obligation. I finish this and then I get the marks for that task, whatever it is. You are on your own. But I'm saying, if you have enough time, spend quality time going through each and everything in a systematic way. Don't jump from user space to kernel space randomly, and kernel space to user space just like that, when especially you are a student. I'm not going to suggest that for any of these quadrants. Actually, the bottom ones are guys who are have experience, they know what they are doing, so they can do that. But if you are a beginner, just try to understand as much as possible first the user space, and then slowly you can traverse towards the kernel space and get the overall idea, and then go back to user space, kernel space, and so you can gain some knowledge actually. But initially, don't try to learn 1,000 things, and don't get on to this fancy stuff actually, because this is, again, I get annoyed every time a student comes, because even he says that he got some exercise in his college. If I see, means it is so damn complicated. I don't know why do the colleges give such a thing to the students who themselves are not aware. Even the lecturers, they themselves are not aware how things work, and they give this kind of shitty work to the students also. So I kind of feel pity on them. But if you have enough time and passion, approach this in a systematic way, and it will help you, especially if you are doing your masters, or even especially if you are doing your PhD actually. So when it comes to freshers, first of all, I can suggest is take some time whether you are ready for this, and if you are ready for that, again it's the same suggestion, go one by one, and first focus on user space, gain some knowledge, gain some good understanding, and then you slowly go to kernel space. Just don't go too deep about some kernel internals and some OS internals which you can't relate. Just start with some very simple basic. See, in this video I don't want to give something which earlier I talked about, which is that roadmap of kernel. Hence I'm kind of staying away. Okay, hence you just go slow and read about the overall kernel. Since Linux is a monolithic kernel, try to understand and try to compare with microkernels, try to understand the kernel architecture, and then slowly you can go step by step, and eventually just you need to explore the kernel source code. So because you are going to work in C language, and obviously you need to have some skills to read somebody's code. As I say, or as industry says always, it doesn't matter whether you know coding or not, but you should have skills to read someone's code actually. So first gain that skill. You are not going to do coding all the day. Okay, you are supposed to read somebody's code more, and you are going to spend more time on that rather than you doing a code by yourself as a beginner. Hence, try to pick those skills. You do any code, you try to understand what it is doing, run it and see the results, and then do back and forth. So hence I'm saying, even if you want to get into driver development and stuff, spend considerable amount of time with the whole kernel itself, okay, rather than jumping onto quickly towards the driver development. Of course, sometimes some of these institutes and all do, but I don't much encourage that approach at all, because what's the point of doing something which you are not aware was first how the kernel itself works actually. So unless you don't get that know-how, why do you need to get into something which is so? Hence I'm saying again, if you are into that, you can come, and as you have various avenues. One is you can become a kernel, this thing, whatever, as I discussed in that video. So hope this gives some overview. There is one approach for working professionals I want to give is, see, these guys are been in industry for long time, around 10-15 years, so they know, I mean, they are quite accustomed with a certain way of doing things. Okay, so they expect the same method I apply for this as well. Okay, as I say again, this every category, this bottom most every category I can split into two ways. I mean, one is they are just passionate, they just want to casually learn. The other one is they just are very serious actually, and they want to implement. Okay, so there are two things are there in both categories. Okay, both of them, they are either passionate, okay, or they are either serious and they want to implement, and they themselves want to become a developer. So hence I am saying, in either case, if you are passionately learning, that's fine, but if you are very serious, you approach in the same method. This is a bit different if you are coming from complete user space, C++ development. I had earlier one student who also happened to be working in some IoT and stuff like that. But if you are coming from that background, it takes a while to get into that, and slowly, once you grasp, you get very comfortable. But initially it takes a while, because you are coming from a complete different type of workflow or your domain expertise. Same thing it happens if you are coming from say like microcontroller programming and stuff, and you want to come towards this side. It takes some time, because here it's more to do with the software, and very less you touch the hardware, and there is a lot of abstraction happens. This is one thing I thought of emphasizing in this video, is there's a lot of abstraction happens. So first, forget about direct device interaction and wasting your time, because every time I get any microcontroller or embedded guys, they just want to see that how this OS talks to the hardware, how this talks to the hardware. Leave that. I mean, the OS itself is not done for that. Okay, the main purpose of OS is to create abstraction, and if you don't understand the Maya or this abstraction, what's the point of learning OS? So just understand how the OS creates this Maya. Okay, the abstraction is the Maya, because it creates that Maya for the user space. So just get that, and that's where the whole fun is about learning the OS. So hence I'm saying, if you're a working professional, just see that how you can come towards this sort of approach. Okay, so initially it will be difficult by nature of your career or workflow, but eventually you get comfortable. But again, as I say, the most troublesome is this freshers, because they just confused whether to go or not, whether to fully pursue this or not. And for them I can say, like, go step by step, and if you are students, again, go step by step. Just try to get understanding of proper user space. Just try to become an expert in one thing. Okay, don't jump into million things which your dumb colleges makes you teach actually. Okay, one day they teach you about some I had like that in my semesters. Although I'm a guy who passed in distinction, I can say it really, like, education system throughout the world is flawed actually. So one day they teach about compiler design, next day they teach about some logic gates, and next day they teach about some SQL fundamentals, and or database and SQL fundamentals. Another subject you will have about some operating system. After that you have some mathematics and all sorts of bullshit activities. Hence I'm saying, it's just the worst way to approach anything in life. Okay, hence unfortunate thing is, this is why you finish the college, you are not going to be anywhere useful for the real world industry. Hence, whenever we guys tend to recruit any fresher, we just don't like at all, unless until he have one thing he knows proper, and not talk about some million bullshit stuff actually. He just need to be an expert in one thing, and he should have that confidence. He should have that somewhat a sort of a know-how where he can explore himself with others guidance. He can also able to explore and do things and stuff. So hence this is something any beginner should pick, and you should know lesser is better when it comes to beginners actually. Because you need to know something which is adequately enough, so that you can work full time for a job, versus you know many things, but you just know all random stuff, but you are not an expert into anything. People don't people like that we don't like in the industry some most of the times. Okay, hence I'm saying, and even say if you attend a job interview, they may ask various things, but sometimes they are casual about certain rounds, interview rounds. Okay, suppose if you go say Cisco or somewhere, they may ask about OS, they may ask about C, they may ask about any networking stuff, and they may also ask about your family and other passions and stuff. I'm just giving an example. Cisco I just giving as a random example, because apart from this they may also have usually networking round actually. So hence I'm saying, if I'm the team head, and I want a guy who wants to who is supposed to work in R&S stuff, R&S team, which means routing and switching, so I will expect that he is somewhat pakka or an expert in networking part. And if he is not having good know-how in operating systems, although I have kept a round to judge his OS skills, so I may ask various questions about Linux kernel and other this mutex semaphore, all this bullshit. Okay, so I may do that, but in case if he doesn't if he is not done well, I can still excuse him. I will just say that anyway this is not I'm looking for. I want him to be a networking expert, but I want him to be working in some user space components at this point of time once he gets recruited. Hence my focus will be shifted towards language or coding skills, and then this networking skills. Hence I'm saying, so this is what it is. So most of the times you may attend an interview with several rounds, 8 or 10 rounds, but only few rounds they see the core expertise of you, and that will have more weightage, not all the rounds together. So 8 rounds, in that maybe 1-2 rounds will have lot of weightage. The other rounds are just it's just it's just done as as a part of that process actually. So this is what it is. Hence I'm giving you an insight. If you are a fresher, if you are studying in college, focus one path you want to go. You want to become a DevOps, focus on that. You want to become a data scientist, focus on that. You want to become in systems software developer, like I said, there are various avenues. Later you can go there, but the whole thing is bound by something like this. So somewhere it is bound by this. Of course I can't strictly say that, because again there are some categories of embedded microcontroller programming and also board design, chips design. So let's not confuse. They may be not completely related to that, but in a way this is a sort of starting point to understand the system internals and then slowly diverge from there actually. So hope this video is giving some insights in terms of getting the first level of becoming a system software developer or engineer. So if you have any queries, you can be in touch with me in mail, WhatsApp, or if it is a small query, we can discuss in YouTube comments as well. So hope you enjoyed this show. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.